You pick up a bottle, twist the cap, take a sip, and toss it aside without a second thought. It feels simple, disposable, almost effortless. But that bottle has already lived an entire industrial life before it ever touched your hand. Inside a water bottle factory, nothing is accidental. Every curve, every gram, every second of production is controlled with precision that borders on obsession. What looks like a basic object is essentially the result of heat, pressure, chemistry, and engineering work in perfect sync. And it all begins with something that looks nothing like a bottle at all. Before a bottle exists, there are pellets. They are small, smooth, and almost harmless in appearance, usually clear or milky white. Each one is about the size of a grain of rice. These pellets, often called nurdles, are the raw material of modern plastic manufacturing. They are uniform for a reason. Factories rely on consistency. Each pellet must melt the same way, flow the same way, and behave predictably under heat. Even a small variation can affect the strength or clarity of the final product. Millions of these pellets are stored in massive containers ready to be transformed. At this stage, the material is stable, easy to transport, and efficient to handle. It can be shipped across countries or continents without losing quality. That is part of what makes plastic so dominant in manufacturing. But once these pellets enter the production line, everything changes. The first real transformation begins with heat. Pellets are fed into large machines where they are gradually heated to temperatures around 500 degrees Fahrenheit. Inside these systems, rotating screws push the pellets forward as they soften, then melt into a thick, flowing liquid. This is not random melting. Temperature must be controlled carefully. Too low and the material will not flow properly. Too high and the plastic can degrade, losing strength or clarity. Sensors monitor everything: temperature, pressure, flow rate. The goal is to create a perfectly uniform molten plastic ready for shaping. At this point, the material has lost its original form completely. It is no longer a pellet. It is a controlled stream of liquid polymer, ready to become something entirely new. Instead of forming bottles directly, factories take an intermediate step. The molten plastic is injected into molds that create small, thick pieces known as preforms. These look like test tubes with threaded tops. If you've ever noticed that every plastic bottle has a similar neck design, this is why. The neck is fully formed at this stage. Preforms are dense, compact, and surprisingly strong. They contain all the material needed to create a full-size bottle, but in a condensed form. This step serves several purposes. First, it allows precise control over how much plastic is used. Each preform is engineered to match the final bottle size and strength requirements. Second, it improves logistics. Preform takes up far less space than finished bottles, making them easier and cheaper to transport. And third, it separates production into stages, allowing different facilities to specialize. One factory may produce preforms, while another transforms them into bottles closer to where they will be filled and sold. At this stage, the bottle still does not exist in its final shape, but the blueprint is already there. Before a preform can become a bottle, it must be reheated. This might seem counterintuitive. After all, it was just cooled into a solid form. But the second heating phase is different. The goal is not to melt it again, but to soften it just enough to make it flexible. The preform is carefully heated so that its body becomes pliable, while the neck remains rigid. This is critical. The neck must retain its precise shape to ensure the caps fit perfectly later. Timing and temperature control are everything here. If the plastic is too soft, it can stretch unevenly. If it is too rigid, it will not expand properly. Once the preform reaches the right state, it moves to the most dramatic step in the entire process. This is where the magic happens. The softened preform is placed inside a metal mold shaped like the final bottle. Then a burst of high-pressure air is injected into it. In an instant, the preform expands. The plastic stretches outward, pressing against the walls of the mold. Every curve, every indentation, every detail is formed in seconds. A piece that was only a few inches long can expand several times its size almost instantly. This process is called blow molding. It is fast, extremely fast. Modern systems can produce thousands of bottles in a very short time, all with nearly identical dimensions. But speed does not come at the cost of precision. Sensors monitor the thickness of the walls, the alignment of the neck, and even the surface finish. If anything falls outside strict limits, the bottle is rejected immediately. The result is a structure that is both lightweight and strong. It can hold liquids, resist pressure, and maintain its shape during transport. What started as a small solid piece has now become a fully formed bottle. Right after shaping, the bottle is still hot and soft. If left untreated, it could wrap, collapse, or develop weak points. That is why cooling is immediate and controlled. Cold air or chilled water is used to bring down the temperature quickly. This locks the plastic into its final shape and gives it the rigidity needed for handling. Cooling is not just about speed, it must be even. Uneven cooling can create stress within the material, leading to cracks or deformation later. Advanced systems monitor surface temperature in real time, ensuring that every bottle cools uniformly. Within seconds, the bottle transitions from a fragile, newly formed object into a stable product ready for the next stage. Before any bottle leaves the production line, it must pass inspection. And this is not done casually. High-speed cameras scan each bottle as it moves along the conveyor. These systems can detect defects that are invisible to the human eye. Tiny cracks, uneven thickness, slight deformations, all are flagged instantly. Artificial intelligence systems analyze thousands of bottles every minute, comparing them against exact specifications. If a bottle fails, it is removed from the line immediately. This level of scrutiny ensures that only products meeting strict quality standards move forward. It also prevents defective bottles from causing problems later during filling, transport, or use. Once approved, the bottles are grouped and prepared for shipment. Some are wrapped in protective film, others are packed into cartons. The method depends on how they will be transported and used. At this stage, companies face an important decision. They can ship fully formed bottles, which are ready to be filled immediately, or they can transport preforms and complete the blow molding process closer to the destination. Each approach has trade-offs. Shipping bottles means moving large volumes of lightweight but bulky items. Shipping preforms is more space efficient but requires additional equipment at the destination. Either way, the goal is efficiency. Every step is designed to reduce cost, save space, and maintain quality. Soon these bottles will leave the factory and enter daily life. What makes this process remarkable is not just its scale, but its precision. Every bottle must meet strict requirements. It must be strong enough to hold liquid without leaking, light enough to reduce material use, clear enough to show the contents, uniform enough to stack and transport efficiently. All of this is achieved through careful control at every stage. Temperature, pressure, timing, material composition, even small adjustments can change the final product. A slight variation in wall thickness can affect durability. A minor flaw in the neck can prevent proper sealing. That is why modern factories rely heavily on automation and monitoring systems. Human oversight is still important, but machines handle the repetitive precision work at speeds no person could match. The sheer scale of bottle production is difficult to grasp. Factories can produce thousands of bottles every hour. Some facilities operate continuously day and night with minimal downtime. This level of output is made possible by the efficiency of each step. Pellets flow smoothly into machines. Preforms are produced in rapid cycles. Blow molding happens in seconds. Cooling and inspection are nearly instantaneous. The entire process is designed as a continuous flow, where each stage feeds directly into the next. There is no wasted motion, no unnecessary delay. It is industrial efficiency in its purest form. By the time a bottle reaches a store shelf, it has already undergone a series of transformations that most people never see. From tiny pellets to molten plastic, from compact preforms to expanded shapes, from hot, flexible material to rigid finished products, each step is essential. Each stage builds on the last. What seems simple on the outside is the result of complex coordination behind the scenes. And yet the final product is designed to feel effortless, easy to use, easy to carry, easy to discard. Inside a water bottle factory, there is no such thing as a trivial step. Everything is measured, controlled, optimized. The journey from pellet to bottle is a demonstration of what modern manufacturing can achieve when chemistry, engineering, and automation work together. It is fast, it is precise, it is scalable. And it all happens long before the bottle ever reaches your hand. The next time you hold one, it may still feel simple, But now you know it is anything but.